Welcome to this module on the evolution of LLMs and prompting in AI. In this lesson, we'll discover how AI evolved from basic language processing systems to powerful large language models like GPT and Gemini. We'll explore key advancements in AI technology, the rise of prompt engineering, and why prompts have become essential for achieving accurate and useful AI outputs. By the end of this module, you'll understand how modern AI models work and how effective prompting helps unlock their full potential. Before the development of large language models, AI systems were very different from what we use today. Most traditional AI systems were rule-based systems. This means developers had to manually define every rule and possible response. The AI could only do exactly what it was programmed to do. Because of this, these systems produced fixed responses. If a user asked a question in an unexpected way, the AI often failed to understand or provide a useful answer. There was very little flexibility or adaptability. Another major limitation was single-turn conversations. Traditional AI could respond to one question at a time, but it could not remember previous interactions or maintain a meaningful conversation. The biggest challenge was the lack of context awareness. Each query was treated independently, so the system could not understand the broader meaning or intent behind a conversation. These limitations highlighted the need for more intelligent systems, ultimately leading to the development of large language models, which can understand context, generate natural responses, and support multi-turn conversations. After traditional rule-based AI, the next major advancement was natural language processing, or NLP. NLP enabled computers to understand and work with human language. Instead of simply matching predefined rules, AI could begin to interpret the meaning behind words and sentences. With NLP, systems could identify user intent, analyze sentiment, and generate more natural responses. This made interactions between humans and computers far more conversational and effective. NLP laid the foundation for today's large language models, bringing us one step closer to truly intelligent AI systems. One of the biggest breakthroughs in AI came with the introduction of the transformer architecture, first introduced by Google researchers in 2017. Unlike earlier NLP models, transformers could understand the relationship between words across an entire sentence or document. This provided better context awareness, allowing AI to understand meaning more accurately. Another advantage was faster training. Transformers process information in parallel rather than one word at a time, making it possible to train much larger models efficiently. This architecture also enabled better text generation, producing responses that are more fluent, coherent, and human-like. Today, the transformer architecture serves as the foundation of all modern large language models, including GPT, Gemini, Claude, and many others. Without this innovation, the AI systems we use today would not be possible. Let's now look at the first generation of large language models, starting with GPT-1, introduced by OpenAI in 2018. GPT-1 contained around 117 million parameters. While that may seem small compared to today's models, it was a major breakthrough at the time. The model demonstrated that a single neural network could learn language patterns from large amounts of text and generate meaningful responses without being explicitly programmed for every task. GPT-1 was capable of basic text generation, producing short and coherent pieces of text. Although its capabilities were limited, it showed the potential of transformer-based language models. Most importantly, GPT-1 served as a proof of concept, proving that large-scale language models were practical and opening the door for more advanced models such as GPT-2, GPT-3, and modern AI systems like ChatGPT and Gemini. Building on the success of GPT-1, OpenAI introduced GPT-2 in 2019, marking a major leap forward in language model capabilities. The most significant change was its size. GPT-2 contained 1.5 billion parameters, making it approximately 13 times larger than GPT-1. This allowed the model to learn more complex language patterns from vast amounts of data. As a result, GPT-2 delivered much better writing quality, generating longer, more natural, and more coherent text than previous models. Another important improvement was its ability to handle longer context. It could maintain meaning and consistency across multiple sentences and paragraphs, making conversations and content generation far more useful. GPT-2 demonstrated that scaling up model size could dramatically improve AI performance, setting the stage for the even more powerful language models that followed. The next major milestone was GPT-3, released by OpenAI in 2020. GPT-3 represented a massive leap in scale, featuring 175 billion parameters, making it one of the largest language models ever created at the time. This dramatic increase in size allowed the model to understand and generate text with remarkable accuracy and fluency. Another breakthrough was its multilingual capability, supporting around 96 languages, enabling users worldwide to interact with AI in their preferred language. GPT-3 was trained on approximately 1 trillion tokens, learning from a vast collection of books, articles, websites, and other internet content. This gave it a broad understanding of knowledge, language, and context. Most importantly, GPT-3 revealed the true power of prompt engineering. Users discovered that the quality of the AI's output depended heavily on how instructions were written. The same model could produce very different results based on the prompt provided. This marked the beginning of prompt engineering as a critical skill in the AI era. Before GPT-3, prompting was a very basic process. Users would often provide short instructions such as write an email and expect the AI to understand exactly what they needed. However, these prompts lacked important details such as the audience, purpose, tone, and expected format. As a result, AI systems frequently produced generic and less useful responses. This highlighted a key lesson in AI interaction. The quality of the output depends on the quality of the input. The more specific the instruction, the better the result. This challenge eventually led to the development of modern prompt engineering techniques that we use today. With the arrival of GPT-3, prompting became much more powerful and important. Instead of giving vague instructions like write an email, users learned to provide clear context, audience details, and the desired tone. For example, specifying that the email is for a UK client about a delayed delivery and should include an apology. This additional context helps the AI understand exactly what is required and generate more accurate, relevant, and professional responses. This shift marked the beginning of modern prompt engineering, where carefully designed prompts became the key to unlocking the full potential of AI models. As AI models became more powerful, people noticed something interesting. Better prompts consistently produced better results. This discovery led to the creation of prompt engineering as a dedicated discipline. Instead of simply asking questions, users began designing and optimizing prompts to improve accuracy, relevance, and output quality. Over time, prompt engineering evolved into a structured process involving testing, refining, and evaluating AI instructions to achieve the best possible outcomes. Today, prompt engineering is recognized as a valuable professional skill, helping organizations get the most from AI systems and enabling prompt engineers to play a key role in AI-driven projects. With the arrival of GPT-4, AI became significantly more capable and reliable. One of the biggest improvements was advanced reasoning, allowing the model to solve complex, multi-step problems more effectively. GPT-4 also became much better at following detailed instructions, producing more accurate and consistent responses. In addition, it reduced many of the hallucination issues seen in earlier models, making outputs more trustworthy. As a result, prompt design evolved into a professional skill, and organizations began investing in prompt engineers to maximize the value of AI systems. Today, we have a new generation of powerful AI models, including Gemini, GPT-4o, Claude, and Llama. These models are far more capable than earlier LLMs. They can generate high-quality text, analyze large documents, and understand multiple types of content, including text, images, audio, and video. This capability is known as multimodal understanding, allowing AI to work across different formats rather than just text. As a result, modern LLMs are being used in education, business, customer support, software development, and many other industries to improve productivity and decision-making. Prompting has evolved significantly over time. In the beginning, users gave simple commands, such as write an email or summarize this text. As AI became more capable, prompts evolved into detailed instructions that specified tone, format, and objectives. The next stage introduced context-rich prompts, where users provided background information to improve accuracy and relevance. Today, we use structured prompting frameworks, combining roles, context, examples, and expected outputs. This evolution has transformed prompting from simple commands into a strategic skill that helps organizations achieve better and more reliable AI results. Modern prompting is about giving AI clear and structured instructions. First, provide clear instructions by stating exactly what you want the AI to do. Second, include context so the AI understands the situation, purpose, and audience. Third, define constraints, such as the tone, length, or any specific requirements. Finally, specify the output format, whether you want a paragraph, bullet points, table, or report. Following these 4 practices helps produce more accurate, consistent, and useful AI responses. Today's large language models are capable of much more than simple question answering. They can create content such as emails, reports, blogs, and marketing materials. They can also summarize lengthy documents, assist with research, and support business communication by drafting professional responses. In addition, LLMs can help with decision-making by analyzing information and providing recommendations. However, these powerful capabilities depend heavily on effective prompting. The better the prompt, the more accurate, relevant, and useful the AI's response will be. Looking ahead, the future of LLMs and prompting is incredibly exciting. Models will support larger context windows, allowing them to remember and process much more information at once. Multimodal AI will seamlessly work with text, images, audio, and video. We will also see more advanced AI agents that can perform tasks autonomously and interact with multiple systems. In addition, automatic prompt optimization will help AI improve prompts on its own. Finally, enterprise AI systems will become deeply integrated into business operations, making AI a core part of decision-making, automation, and innovation. Let's recap the journey of AI and prompting. We started with rule-based systems, which followed fixed instructions. Then came natural language processing, enabling computers to understand human language. The introduction of transformers was a major breakthrough, allowing AI to understand context and relationships within text. This led to powerful models such as GPT and Gemini, capable of generating human-like responses. Today, effective prompting has become a critical skill, helping us guide AI to produce accurate, relevant, and valuable results. As AI continues to evolve, strong prompting skills will remain essential for unlocking its full potential. Congratulations! You have now explored the complete journey of large language models and prompt engineering. We covered how LLMs evolved from GPT-1 to today's advanced multimodal models. You learned how prompting evolved from simple commands to structured frameworks that produce more reliable results. We also explored practical prompting techniques, including context, constraints, and output formatting. Finally, we looked at future trends such as AI agents, multimodal AI, and enterprise AI systems. These skills provide a strong foundation for working effectively with modern AI technologies and preparing for the future of AI-driven innovation. Let's quickly recap the evolution of LLMs and prompting. In 2017, the transformer architecture laid the foundation for modern AI. Between 2018 and 2020, we saw the rise of GPT models from GPT-1 to GPT-3. During 2021 and 2022, prompt engineering emerged as a key skill for improving AI outputs. From 2023 onwards, advanced models like GPT-4, Gemini, Claude, and Llama transformed the AI landscape. Today, we are entering the era of AI agents and advanced LLMs, capable of reasoning, automation, and multimodal understanding. Thank you for completing this module on the evolution of LLMs and prompting in AI. You have explored how AI evolved from rule-based systems to advanced models like GPT and Gemini, and learned why effective prompting is essential for achieving high-quality results. Keep practicing these techniques, as prompt engineering is becoming one of the most valuable skills in the AI era. Thank you for learning with the London School of Emerging Technology. We look forward to seeing you in the next module.
We hope you enjoyed this video. Ready to take your AI skills to the next level? Enroll in our self-paced Prompt Engineering Mastery Beginner to Advanced course and learn how to create powerful AI prompts using ChatGPT, Gemini, Claude, and more. Build industry-ready prompt engineering skills, explore real-world AI workflows, and stay ahead in the AI revolution, all at your own pace. Use coupon code to get 15% off today. Scan the barcode or visit the course page now to start your journey into prompt engineering.